right, so as I said, today we're going to be solving inequalities, and we're going to be rewriting them in this form that's called interval notation. Up here it shows us what interval notation would look like. This is saying that the solution would be all the values between A and B, but not including A and B. If I want to include B, look at what I have to use. What do we use? Not a parenthesis, but a bracket. Okay, so if I say a value is included, like we are here, we're saying that the B value is included, that means I'm going to use a bracket. But this is saying that A is not included, so therefore we had to use an open dot. All right, if we're going all the way down, let's look down here, all the way down so that all the values that are greater than A, that means that the first value I come to is A, and then we're going all the way down here. What are they calling that? Do you guys know what that symbol is? Infinity, okay? All right, so let's solve these problems now. So on this one, we have two problems, and one is saying that this has to be less than -5, or this has to be greater than or equal to 4. Solving this, I would just add 1 here. So we get 2x is going to have to be less than -4, so x is going to have to be less than -2. Solving this, I'd have to add 3. X is greater than or equal to 7. So what this is saying is, to solve this inequality, we need some x value that is less than -2, down here, or the value has to be greater than or equal to 7. So this is how the solution looks just using inequalities. That's a good way to write it with inequalities. But what if we have to use the interval notation? Well, this is saying that I can use -2.01, -2.1, -2.5, -100, -1,000,000, -1,000,000,000. What do you think I could call that if I want to start way down there to the smallest number I can think of? Negative infinity, right? So this I would write as negative infinity up to -2. Would I use a parenthesis or a bracket around the -2? Am I including -2? No, so I use the parenthesis. That means not including, but getting as close to it as possible. The word or in math is the union symbol. That means or. And now I pick back up. Is 7 included? Yes. Do I use a bracket or a parenthesis? Bracket. So this would be the answer in interval notation. So I'd like to see you using interval notation on this whole worksheet. Looking at this, I can see that I can choose any very small number all the way up to -2, but not including. I can use any number that's larger than 7, and I'm even allowed to use 7. Okay? Let's try this one. This is actually saying that this value right here has to be in between -10 and 0. So this is really two problems in one. So what I'm going to do is I'm going to have to add 5 to this section because I'm trying to get x by itself. An inequality symbol is just like an equal sign. So I have to add 5 here as well. Here's another inequality, kind of like an equal sign. So I have to add 5 here. So -10 plus 5 is -5. Then I have the -2x less than 5. All right, what would we have to do now, you guys? Divide by -2. So I have to divide by -2 here, divide by -2 here, divide by -2 here. Does anybody remember what happens to the inequality? Yeah.
You have to flip the sign.
Exactly. We have to flip these inequalities. Negative divided by a negative is a positive. This was less than or equal to. Now it's greater than or equal to x. And this is greater than. And this is -5/2. Now, let's go over here and let's graph this. So this is saying that x has to be less than or equal to 5 halves. Here's 5 halves. I'm allowed to be equal to it. If I have to be less than 5 halves, is that to the right or to the left? To the left, isn't it? So we're talking about down this way. This is saying that x must be greater than negative 5 halves. Here's negative 5 halves. We can't be equal to it. Are we going to go to the left or to the right? Which way is greater than? To the right. So this would be the region we're talking about. As an inequality, this is not written well, because we always want to have our smaller number first. We want this to say x is in between these two values. So we would be better off writing it like this. See how now it makes more sense? X has to be in between negative 5 halves and positive 5 halves. That's what this is saying. So this is the better way of writing it. Interval notation. I look for my smallest number, negative 5 halves. We going to use a parenthesis or a bracket? Parenthesis, good. Comma, up to positive 5 halves. Parenthesis or bracket? Bracket, good. So look at the difference. You don't need to know these names I'm going to say, but this is called a disjunction because it's not all in the same region. This is called a conjunction when we're in between there like that. Right, let's look at this one. Difference. Look at these. Now this. What's the difference? Now we have what kind of new symbol? Absolute value. So let's talk for a minute about what absolute value means. Absolute value. What is it, guys? It means what?
Both sides of 0.
Right, both sides of 0, because it's really the what? Distance, right. Okay, so let's come over here off to the side. You don't need to write this down, just watch. So if I say the absolute value of some number has to be less than 10, think about what that means on a number line. What did we just say absolute value means? Distance from 0. So I'm looking at all of the values of x that have a distance that's less than 10 away from 0. Tell me some numbers that work. Everybody. 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. What else? Negative 1, negative 2. Right. So everything that is in between negative 10 and 10, right? Don't all of these values in here work?
Yeah.
So that means then that any x number that's less than 10, but what else?
Greater than negative 10.
There you go. This is what works, right? Anything in between negative 10 and 10 works. Now let's come over to this one. Instead of just having an x, we have this thing right here. But what has to be true of this 3x plus 1? It has to be in between what? Positive 10 and positive 10 and negative 10. It's got to be in between there because this must be within 10 units of 0. How do we solve this? Go ahead and solve it on your own now. You can look up here if you get stuck, but try it on your own. Write that final answer in interval notation. Raise your hand if you got it right. Raise your hand if you need some explanation. Okay. So what we did there is we can see, what kind is this? I said you didn't have to know it, but do you remember what kind this is? Conjunction, right. Anything in between negative 11/3 and 3 is going to be a solution. Give me some number. What's some number that would be in there? Easiest number to check. I can think of an easier number. 0. If I plug in 0, I get 1. Absolute value of 1 is 1. Is that less than 10? That works, doesn't it? So we're pretty sure we're good. All right, now this one. Let's go over here to similar kind of problem. So this is saying now the absolute value of something has to be greater than or equal to 7. On a number line, distance from 0. The distance from 0 has to be what? 7 or?
Less.
We have to be more than 7 units away from 0. That's what this is saying. More than 7 units away. Or we can be equal to 7 units away. So do 6, 5, 4, 3, 2, 1 work? Are they more than 7 units away? No. Everything over here works, doesn't it? 7 would work. It's 7 units away. That's fine. All these over here work. What else would work? Would negative 6 work? No. What about negative 8? Yeah, that's more than 7 units away. So negative 7 would work, wouldn't it? And then everything down here would work too. So how do we set up this kind of problem then? What did our answer end up being in inequality form? What's true of all these x's, guys? Are they greater than or less than negative 7? Less than. So this answer becomes x's that are less than or equal to negative 7, or x's that are what? Greater than or less than? Greater than or equal to 7. So that's what this turns into. In math, anytime we have a difficult problem, we think of an easier problem, and how do we do that problem? And then we translate that information. This turns into this. X has to be less than or equal to negative 7. So this must be what? Less than or equal to what? Negative 7, because it has to be more than 7 units away, 7 or more units away from 0, or 5x plus 2. Let's look back here again. This is really our 5x plus 2. So it had to be less than negative 7, or it had to be what? Greater than or equal to 7. Good. So now, on these OR problems, you have 2 to do. You have to do this one, get an answer, this one, get an answer, write it in interval notation. Okay, try it on your own. You can look up here if you need help. Somebody tell me their final answer in interval notation. What is it?
Negative 9 over 5, comma 1 over the both of them.
Okay. But that would mean, if we wrote it like that, that's going to mean that we're talking about all the numbers in between negative 9/5 and 1 work. Those aren't the numbers that would work. It's a little bit different than that. Let's go with Justin.
parentheses, negative infinity, comma, negative 9/5, and bracket, and then the or sign, and then bracket 1, comma, infinity, parentheses.
Good. That is correct. Why are we using parentheses around infinity and negative infinity? Yes.
It already implies it goes on, and there's no like set number that it stops at.
Exactly. So we can't ever use a bracket around infinity because that means that we're including it, and you can't truly ever include infinity. Any questions on that? What did this end up being, conjunction or disjunction? Disjunction. It ends up being these outer areas that work. Okay? Anybody have questions? All right, so this isn't even due until Wednesday. So on Monday, we're going to go over the summer packet some more. I'll walk around and help you individually within your groups. And Tuesday, we're going to take the summer packet quiz. And then Wednesday, we're going to start on the material in the journal that I gave you. So make sure you start bringing that journal on Wednesday.